Hey guys, and welcome back to another maths challenge question. Today is a very hard question. Let's have a read of it together. So, a semicircle is inscribed in a quarter circle as shown. What fraction of the quarter circle is shaded? So we basically need to find this shaded region as a fraction of this entire shape. So have a go at that, pause the video, and then afterwards we'll try and work it out together. Okay. So how should we start this question? My first thought is to draw it all out, and in that way we can label the diagram afterwards. So let's have a go at drawing it. So we've got our big quarter circle like this, and then we have a semicircle inside the shape. Cool. So we've got our shape. Now we want to try and label this diagram as much as possible. So if we were to try and find the area of this shape, what information would we need? Well, we know that for the formula for the area of a circle, it's pi r squared. So we're interested in the radius of our shapes. Now note that we have this smaller circle here for the semicircle and a large circle for this quarter circle. So we're going to have two different radii. We're going to have one big radius, which we'll call capital R, and that's the length of one side of this quarter circle. We're also going to have a little radius, this one, for our semicircle. So we've got two different radii in our question. Okay, but where do we go from here? Well, one thing that I've noticed is that this line here is a tangent to the semicircle, because it touches it at a single point. What do we know about tangents to circles? Well, we know that it meets the radius at a right angle. So if we were to connect the center of this semicircle to the point of intersection, it's going to be at a right angle to this vertical length here. So we know that it's going to be a horizontal length. Okay, likewise, for this length at the bottom, that is also a tangent to the semicircle at a single point. So this tangent is perpendicular to a radius as well. So this one's going to be vertical, going up like this. Okay, so since these two lengths here are vertical, and these two lengths here are horizontal, we've come up with a square shape. And all the lengths are little r. Cool, that's good so far, but where do we go from here? I need to try and form some sort of relationship between my big capital R and my little r. Okay, so maybe I can try and find some sort of geometric shape within this to help me out. Okay. Well, where else can I get this capital R? Well, the radius is a length from the center to any point on the circumference. Now, I think the most useful points are going to be this point here and this point here, since it's where this semicircle touches the big circle circumference. So what if I drew a dashed line from this point all the way to this intersection? Aha, I've spotted something that might be useful here. If I draw this triangle out here, that triangle is going to be a right angle triangle. Due to the symmetry of the question, this line here will split the semicircle into half. Okay, let's redraw this triangle just to make it a bit clearer. Okay, so this triangle is going to be here, where this angle here is a right angle. And right angle triangles are useful because we know we can use Pythagoras' theorem on them to work out relationships between the lengths. Okay, what is this length here? Well, it's our hypotenuse here, which is going to be capital R. Cool. What is this length here? It's just going to be little r, since it's the radius of this semicircle. So we can put that in. Okay, now we need to find this length here, which is here. How are we going to find that length? Well, note that this length is the diagonal of this square that we formed. Okay, so if we redraw that square to the side, we know that the lengths are little r for the sides, and to get the diagonal, we just need to do Pythagoras theorem. So the square root of r squared plus r squared, which equals the square root of 2r squared. Cool, so that's going to be our length here. Cool. Now that we've got all the lengths of our right angled triangle, we can do Pythagoras theorem on this right angled triangle. And that will be good because then we'll have a relationship between capital R and little r. So let's do Pythagoras theorem. We're going to have capital R squared equals little r squared plus 2r squared. And let's combine any like terms. We're going to get r squared equals 3r squared. Cool. So now we have a relationship between capital R squared and little r squared. Cool. Now we need to find the area of this semicircle. So what's the formula for the area of a semicircle? It's going to be half pi r squared. And here we're using little r for the radius of our semicircle. So this is for the semicircle. So I'll just put semicircle A for area. Okay, what about my quarter circle area? Well, the formula for the area of a quarter circle will be a quarter pi r squared. And in this case, we're using capital R because that's the radius we used for our bigger circle. Now we can use our relationship that we found just earlier and substitute 3 little r squared into our capital R squared. So we're going to get a quarter lots of pi and then 3r squared. Cool. Now let's find the fraction of this quarter circle, which is the shaded region. Well, that's going to be the area of the semicircle divided by the area of the quarter circle. So we're going to have a half pi r squared all over a quarter pi lots of 3r squared. Cool. And note that we can just cancel out the pi's, cancel out the r squareds, and then we just have numbers left over. So we're going to have a half in the numerator all over 3 over 4. Cool. So we just need to do a half divided by 3 over 4. And remember, when you divide by fractions, you can just multiply by the reciprocal. So we have a half times by 4 over 3. What's that going to get me? It's going to get me 4 over 6, which is simplified to 2 over 3. Cool. And if we look back at our different options for answers, we can see that C is 2 over 3. So that is our final answer for this question, and we're done. Okay, very difficult question. Hope you guys followed along. If you want to see more videos like this, then check them out. Bye bye.